Okay, we're going to start where the lights went out and we lost everything. Maybe those are on a half-hour timer. Maybe I don't need to set my phone. Just when the lights go out, know that it's probably time to start another video. So we've solved all the way to angle theta, and I said if somebody can tell me why it's angle theta, that would be a good extra credit. I don't know, so I'll be learning something if you want to do that. But what is angle theta? Angle theta is the actual lead or lag between the sine wave of the voltage and the sine wave of the current. And remember, we have that little mnemonic we use, Eli the Iceman. And we've been using Eli because we've had inductive circuits, but right now we're at a capacitive circuit. We're moving up in the world to C. So we're going to go ahead and use ICE as our mnemonic. I'm going to go ahead and draw that sine wave. Here's my 0 point. And I'm going to draw my first sine wave. And usually I call that E. And in fact, this time I'm going to call it E, right? That's my voltage sine waves, because I know I've got a voltage source. And I now have to figure out where my current sine wave is compared to that. Well, what I've been doing up till now is saying, okay, this is 90 degrees, this is 45 degrees, so 13, this is 22. It's actually going to be pretty stinking close. And nobody's getting out a measurement to see where that is, but it should be relatively where it is. If you draw your sine wave at 90 and you found 13, I'm going to mark it wrong. But give me a sine wave that's close and label it as such. So if this was an inductive circuit, I'd go from there and I'd draw my sine wave, say, from this point, right? And it would lead the whole way. But a capacitive circuit, current actually leads the voltage. So the voltage is going to be behind the current. So instead of drawing my line there, I need to actually back up 13.418 degrees, which I'm going to say is right about here. And I need to draw that current sine wave leading the voltage lagging. And I want to make sure, and I want to label that current sine wave, and I want to say that this right here is my 13.418 degrees, 13.42 degrees, whatever you want to call it, and show that current is leading the voltage by that amount. Again, this number in degrees, because remember this sine wave represents 360, that's the same as this angle right here. And this triangle can represent my power apparent and my power true. So the angle between power apparent and power true, so because cosine is adjacent over hypotenuse, that's why we do the inverse cosine to get that. Those of you who care about how that trig works, how we got to that point. But that's kind of a cool thing. I'm going to not do the the parallel circuit this week after all. I lied at the beginning of the video, imagine that. Because this took a whole half an hour plus. Again, I'm at 2 videos. Take a look at the chapter. It's a very good chapter on this. I forget the number of the chapter, but it'll be on Moodle, that talks about parallel series. We didn't do parallel. RC series circuits, and explains it to you. There will be a quiz just like the last several weeks. It's going to be one circuit that I show you how to do. Hopefully I show you the right way this time. Thank you, Marcus Gibson, for pointing out my error last time. Several of you said there was a problem. Marcus actually figured out what my problem was. I used the wrong value in one of my early parts. And a lot of you have done that so far. Show your work on these quizzes, because if you screw up a value early on, but you can show me how you used that wrong value throughout but did everything else right, I'll give you credit on the rest of it. But if you just put your answers down on a piece of paper and I can't tell how you got there and they're wrong, they're wrong. So show your work if you can. If you're getting everything absolutely right, then you obviously know how to do it, and I'm not going to worry about it. Please, you guys, get your submissions in on time. They need to be submitted as PDFs. 99% of you are doing them as PDFs, and about 95% of you are doing them on time. I am not going to remind people anymore. If I've reminded you once already, you got your one reminder, okay? I don't mean to single anybody out, but I'm going to give everybody one shot, and if it's Thursday night and you haven't turned it in, I'm going to give you a text, phone call, email, whatever I can, and say, hey, I need your work, and if I don't get it after that, I don't got it. And if you've already had that reminder or something from me, it's up to you. You guys are adults. This is something that's required for you to stay working as an electrical apprentice. So you need to be attending these video things. I mean, I feel like I've made this super easy for people to do. You can watch the videos anytime you want to. You can take the quiz anytime you want to. You just got to turn it in time for me to be able to grade it so I can tell the JTC, yes, this student attended this week. This student did what I asked them to do, and so we're going to give them credit as being in class. This whole thing is, we're making it up as we go along. I am, you are, the school is, but these are the things we need to do to make it at least somewhat legit. So if the state audits us later and says, hey, what did you do? Can we really give this apprentice a license at the end of this program? We can say, yes, you can. We had a curriculum and we did it through. So enough preaching, sorry about that. Like I say, 95% of you guys are doing great. Take a look at this. There'll be more soon. And that's it.